video is about learning to draw the superposition of two waves. Just write that here. The superposition of two waves and how to draw it. Okay, so let's have a look here. Say we've got one sinusoidal graph, y equals sine of x. Might look like that. And let's boost the amplitude. Let's make the amplitude, instead of it being 1 here, let's make it 2. Okay, and let's take another graph. Y equals, again, sine of x. But maybe let's alter the frequency, alter the period here. So we've actually doubled the frequency, which is halved the period. So say we want to add these two graphs. So let's have a look at this. I'll just sum them over. Hold on, I'll zoom in a little bit. I'll just sum them over one full period here. From here to here. I'll need a bigger photo than that. One full period. Okay. So we're summing these two graphs. So what do we actually do? Well, all we're doing, okay, we're drawing superposition. And all we're doing, is adding amplitudes. It's actually better to say adding the vertical displacement from both waves for every x position. So in this video, I'll look at adding the vertical displacement from both waves for this x position, 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 and for this x position. Okay, I'll try to use the colors that make sense. So at this point, x equals 0. This is x and this is y. At x equals 0, the displacement from the green wave is 0, and the displacement from the blue wave is 0. So our point's just going to be, let's use that. We're there. Okay. At this x position, our displacement from this green wave is about 1, 2, 3 1/3 squares, which is about 0.8 or so. So we need to add this displacement, this 0.8, onto where we start here, this wave. So we need to go 1, 2, 3 and a bit, 0.8. So that's our point there. Here, again, our displacement, here it's about 0.9. So we need to add that 0.9 onto this displacement from the blue graph. So we go, well, 1 would be 1, 2, 3. That would be 1, so we'll come back a bit. We're about there. Here, the y displacement of this x point is 0. So we need to add the displacement contribution from the green graph, which is 0, onto this graph here. 0. For this point, our displacement for our y displacement from the green graph is negative, what's that? Negative 0.95 or so, almost taking off a whole 1 unit. So we need to subtract almost a whole 1 unit from this point. 1, 2, 3, 4, a little bit less than our points there. That's a bit unclear there. It looks like I've tried to draw there. Okay, here our displacement is about negative what? 0.7. So 0.7. And so here we need to subtract from here 0.7, which is, that's going to be 0.75, so we're going to be a bit above the x-axis there. Here 0 plus 0 equals 0. Here our positive displacement here is almost 1, so we need to add almost 1 to here. 1, 2, 3, 4, almost 1. Our point's going to be there. Here, let's do it another way. Let's think about adding on the blue to the green. So here we've got a negative blue displacement of 2 units. 2 units. So or let's say of a displacement of negative 2 units. So we have to subtract 2 from this point. As 0 minus 2 is just minus negative 2. So we end up there, which is obvious. Here, our blue displacement is 1 unit plus another 0.3 or so. That's 0.25, 0.3. So that's a displacement of about negative 1.3. So we need to think about, we're starting here and we're subtracting 1 and another 0.3. About there. And at this point, 0 plus 0 equals 0. And then we can join up those waveforms. Join up those dots. So it's this dot, joining up that dot, 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 and that dot. And that's going to generate a waveform that looks something like this. Okay, so how can we check this? Well, if we go back to our Desmos, I can actually write another equation here, which is y equals, we've got our initial, 2 sine of x, this one here, 2 sine of x, and we can add our sine of 2x. And does that look like what we had? Remember, we were only going to here. It goes up, down, goes flat, down, and then comes back. Yeah, it does. We probably should have brought this. Oh, hold on. I did do a point in there, so I missed that. So this should actually go more like this. Coming up. That point there. Don't miss that one. It's going to be symmetrical, isn't it? Like that. And that is what we see in this purple line. In this purple line here. What are the key points here? Well, the key points are going to be, if we come back to this diagram, when 0 equals 0, if you draw this and your line does not go through this point, you go like this, that displays a lack of understanding that the point here has to be 0 because we've got 0 and 0. Another key point is this point. Because this is 0, a graph has to go through this point here because it's 0 plus this displacement. This has to be 0. This has to be 0. This 0 plus this displacement has to be there. This point has to be 0. So if you have to ensure that these ones are no-brainers, so even start with them, and then do a few intermediate points to see where you're going. Hope you now know how to draw superposition by adding all the vertical displacements from both waves for energy for every. So I'm just distracted by my alarm. For every x position.